Hi, in this tutorial we're just going to go over ionic bonds. Now, if you remember from the electron configuration tutorials, electrons tend to fill up the shells in this kind of order. So the first shell will be filled up with 2 electrons, and the next shell will be filled up with 8 electrons, and the next shell after that will be filled up with 8 electrons as well. So we're going to take sodium and chlorine as examples because I thought that would be quite familiar to most people as sodium chloride. And sodium chloride is typical table salt. And it's also a very good example because we're only dealing with 1 electron at a time. So for sodium, for it to be stable, and the reason it's actually in group 1 of the periodic table is in fact it's got 1 electron in its outer shell. So the 1 electron in its outer shell actually complements the protons. If you see, it's got 11 protons in its nucleus, 11 electrons in its outer shell, and these 12 neutrons are in the nucleus as well. Now, if sodium was to become a stable closed shell system, it would have to lose that electron. Now, if it lost that electron, it would become positively charged because it wouldn't be able to balance off the protons. So what happens is when sodium and chlorine are near each other, if you will, it loses an electron and it helps chlorine, it like complements chlorine by filling chlorine's shell by giving it an extra electron, and that leaves sodium positive and chlorine negative because in its neutral state chlorine's got 17 electrons to complement the 17 protons in the nucleus. So because it's took on an extra 1, it becomes negatively charged, and this is my shorthand for positive and negative. So that's a plus and that's a minus. So that becomes an ionic bond because once that happens, once that electron moves across into the other atom that can take the electron. So you might have lots of sodiums around, but another sodium is not going to take another electron. It's certainly not going to take another 7 electrons. So what happens is chlorine is around, and instead of bump into each other, boom, it pops across, and you end up with something with a network of positive and negative charged atoms. So if I draw the positive charges like that, I'll just draw a few around because I can draw it right. So these are positively charged atoms floating around, and I'm drawing it in a particular way, and hopefully you'll see in a second. I'm going to change the colour now to blue, say, and I'll draw the next one slightly bigger. Now I'm just drawing it slightly bigger, it might not be, but in this case it will be. And that's the atomic radius I'm trying to make bigger. And what we've got is plus and minus pairs all mixing together, look. Okay. Now that's formed what's called a lattice structure. So it's not a lattice, it's a lattice. So the plus minus plus minus plus minus not only goes on a flat plane like this, it also stretches backwards into a 3-dimensional plane. Now I've got a picture off Wikipedia here for the lattice structure of sodium chloride, and if I just draw a picture of it as well, because it's quite a crystalline compound, and a lot of you have seen table salt, but you might not have seen big crystals like this. So you have to forgive the blue thing that keeps coming up. That's the chlorine, and the little ones are the sodiums, and you see that they alternate, and that's exactly what happens in the crystal structure. So what happens with ionic bonded species, they form these crystal structures, these lattice networks of plus and minus, plus and minus, plus and minus, and that makes the solids really, really crystalline and have high melting points as well, because they don't really want to move around. Now in the solid form they're pretty inert and okay. If you melt them, they've got high melting points, but if you melt them, these electrons move around, and the movement of electrons means they can conduct electricity. So they become, when they're molten, they can conduct electricity. And also, if you say took a beaker and added some water and added some salt, then that solution with these in, let's see if I can do this. Just gonna, what I'll do, I'll just shrink that down a little bit. If you get water, I'll shrink it down a little bit more. Oops, that didn't work. Put that back in there. And water with all these little ions floating around, then what will happen is they will disperse within the water. So if I just draw another, this is going to go horribly wrong, but here we go. If I draw water as a green molecule in there, water will fit in all these gaps here. Yeah, so that it will lose its ionic bonds because water likes to bond with them as well in a special way. So water does that, and what happens, if I draw it over here, so these are water molecules, it loses that lattice structure and becomes a liquid, an ionic liquid. And I'll draw the chlorines in blue again, and they just get scattered around, so they don't become pairs anymore, and that actually can make similar properties to the molten state. I'll just draw the red, the sodium. So you see they're all floating around now independently and not forming this lattice structure. It all breaks apart in water because water likes to bond with each individual one, and the liquid solutions can actually conduct electricity too if you put electrodes in. So one of the properties of, well, a couple of the properties then of ionic bonds, bonded species, are they're incredibly complex lattice structures, and they go on and on and on and on, and you get lovely crystalline material. And also in the molten state they conduct electricity, and I'll put these up on the website as well, these little pointers. And also in the liquid form, if they're dissolved in water, they dissolve in water quite well because they're ionic, and water likes to just wrap itself around these charges and break them apart. It just loves doing that. And the liquids that have ionic species present can also conduct electricity too. So that's pretty much it for this introduction to ionic bonds, and I'll put a few more things up on the website just so you can have a look as well. So bye for now.